Welcome to Ask and Learn.
According to the reaction, for any isothermal process, a volume should be increasing. Hence, for isothermal processes, PV will be equal to constant, or we can represent it as P1 V1 equals to P2 V2. For increase in volume, we can say that the newer volume will be higher than the first volume, or we can represent it as V2 divided by V1 is greater than 1. Hence, value of P1 divided by P2 will be also greater than 1. So we can make an entropy formula, that is delta S entropy is equal to NR natural log value of P1 divided by P2. If the ratio of P1 by P2 is greater than 1, it is directly proportional to the value of delta S. Hence, delta S is also greater than 1. So value of delta S will be also greater than 1, have a positive value. Hence, entropy is also a positive. For second option, option B, we calculate the work done by system dW equals P dV. For an ideal gas, PV equals nRT. Hence, we can incorporate both. P equals nRT divided by volume. We substitute this formula into the work done equation. So dW will be equals to nRT divided by volume dV. We integrate this equation, so that gives us W equals nRT natural log V2 divided by V1. We substitute the values of number of moles, R, temperature, volume from the quotient into this equation of work done. So W will be equal to 0.2 multiplied with 8.314 with 300 Kelvin for temperature, natural log 18.5 for volume 2 divided by 10 liters for the first volume. So work will be 306.87 joules. According to isothermal process, the internal change in energy, that is du, will be equal to 0. But according to the first law of thermodynamics, we have an equation dq equals du plus dw. We substitute the values. Dq equals 0 plus dw. Dq value will be equals to dw. We have second law of thermodynamics that says delta S equals Q divided by T. We substitute the value of Q and temperature, that gives us delta S equals 306.87 divided by 300 Kelvin. So the entropy turned out to be 1.0229 joules per Kelvin. Next, moving towards option C. For an isothermal process, change in internal energy is 0. As we have shown, du will be equal to 0. So calculating delta S equals N R natural log V2 divided by V1. Here, S is entropy, N is number of moles, R is a universal gas constant, V1 and V2 are initial and final volumes, respectively. The temperature is required to change in entropy as long as the expression is taking in place under isothermal condition. So therefore, there is no need to specify temperature to calculate entropy change. Thank you.